Hey, we're on to section 3.1, solving systems by graphing. What do we need to know? We need to know that systems of equations are, or is, two or more equations with the same variables. So we can have 2, 3, 4, sometimes 5 equations, all having either x and y, g, h, a, b, c, and so forth. To solve a system of equations, we want to find the ordered pair that satisfies all the equations. There are 4 basic methods that we use to solve a system. The first one is based on today. That's what we're doing is graphing. There is also substitution. We will also look at elimination and then sometimes use matrices. So the first thing we have to understand is we need to classify systems. So we classify systems by 2 main different ways. We classify the solutions of a system by 2 different characteristics. The first one, we need to know, does it have a solution? So if it has a solution or it does not have a solution. Do the lines intersect? Do they not intersect? So we look at it as consistent and inconsistent. A consistent system is a system that has at least one solution. So there is some type of intersection. A system that is inconsistent is one that has no solutions. Okay, the second thing is we want to look at, well, let's throw the inconsistent away because it doesn't have a solution. If it does have a solution, we're going to look at, well, is it one solution or is it a number of solutions? So we're going to call it dependent or independent. A system is independent if it has exactly one solution. The lines do cross one time. Or a system is dependent if it has infinitely many or just many solutions. There are 3 possibilities for the number of solutions of a 2 by 2 system. Okay, so these are 2 equations. Okay, the first possibility, yes, we can get lines crossing, so we'll call that intersecting lines. We can also get lines that don't cross, so we'll call those parallel lines. And the last one is, well, let's see, we did parallel, we did crossing. Well, what if they're right on top of each other? So we call that the same line or just one on top of each other. Okay, so based on those 3, we want to know how many solutions do we have? Well, these lines on number 1 intersect 1 time, so therefore we only have 1 solution. 2, do they intersect? No, they don't, so we'll call that no solution. And these, if they're right on top of each other, well, they intersect many, many, many times, so we'll call that many solutions. Okay, now we look at the classification. Just from the last little setup, okay, we need to know, does it have a solution or does it not have a solution? If it's consistent or inconsistent. And then based on that, we will look at, is it dependent versus independent? Well, this has 1 solution, so it is consistent, and it also is 1 solution, so therefore it's consistent and independent. No solution, well, since it's no solution, it's inconsistent, and we stop there. There is no dependent or independent. And with the same line, many solutions, it does have a solution, so it's consistent, and it's a bunch of different times, so they are dependent. Okay? Now, what if we don't do graphing? What if we solve this algebraically? Okay, there's not really a picture. We got to figure out, well, what happens when you solve it algebraically? Well, according to intersecting lines, when we solve it, you're going to get an x and a y value. So that is our point or our solution. Parallel lines. Okay, and same lines. These 2 are kind of similar because what you'll notice when you solve an equation is the variables drop out. So the x's or y's or z's, they all drop out, and all you're left with is numbers. So if they're parallel lines, and we know there's no answer, then what you're going to see is you get a false statement. We'll have 2x plus 5 equals 2x minus 3. When the 2x's cancel out, you end up getting 5 equals negative 3, which is not true. So therefore, it's a false statement. There is no solution. With the same line, it's the same idea, but we do have a solution, so we're going to get a true statement, and that in terms just says, well, 5 equals 5, so that's all the time. So therefore we get many solutions, or many different points that actually solve it. When we classify a system without graphing, what we want to do is we want to be able to look at it or manipulate it and then say, is it consistent, independent, consistent, and dependent, or inconsistent? So what we can do is take these two equations here and we can solve for y. We'll get the top one. If we add the 3x over, you end up getting y equals positive 3x plus 4. And then with the bottom one, you can do one of two things. Let's subtract x over. So we'll get negative 1/3 equals negative x plus 1. And to get rid of that fraction, we're going to multiply by negative 3. So by multiplying by negative 3, we're going to get y equals 3x minus 3. So we have these two equations. What do we notice about them? Okay, they have the same slopes, and they have different y-intercepts. So they're going to cross at different points. They have the same slopes. So are they going to intersect? No. So do they have a solution? No. So if two slopes are the same, moving down the next bullet, if two slopes are the same and the y-intercepts are the same, then we know it's the same line. Well, if it's the same line, it is consistent, independent. Okay, if the slopes are the same but the y-intercepts are blank, then it is inconsistent. Well, if it's inconsistent, we should know that it is yes. They don't intersect, so they're parallel. So the y-intercepts are different. Okay? Which, if you notice, this is what we have. So therefore, if you look at the bottom at the little, therefore, our system is inconsistent. And then the last blank, if the slopes are blank, then it is consistent and independent. Consistent means it has a solution. Independent means it's one, so the slopes would have to be different. Therefore, you get an intersecting line. Putting this all together, we want to solve the system equations by graphing. Mentally check your answers. Then describe the types of lines. So solution classification. If we take the first one, in order to graph again, make it easier. So y is by itself. So what we're going to do is divide by 2. We'll move this down here, and you end up getting y equals 1/2 x. If I flip it around, we can say also y equals 1/2 x plus 0. If I do the bottom one, we're going to need to subtract the 2x over. And then if we divide by negative 1, we end up getting y equals 2x minus 6. So if we graph the y-intercepts, use our slope, or make it a table of values, notice we have different slopes, different y-intercepts, so we know that we're going to get an intersection of lines. So if you graph it, you should get this. Okay? Sometimes it does help if I just circle that point that's right there. And if you notice, that is over 4 and up 2, so my solution is 4, 2. Okay, the classification, since it has a solution, it is consistent. And being consistent, it is 1 point or many points. Well, it's only 1 point, so we'll say consistent and independent. Go ahead, do 2 and 3 by yourself. Check back with me in a second. Hit pause. We'll see you here. Welcome back. Hopefully you got what I got. If you notice, by solving number 2, by solving the top equation, we get y equals by solving the equation on the top of number 2, we get y equals 3/4 x plus 3, which the bottom one is already solved for y equals 3/4 x plus 3. They are the same line. Therefore, we get this one graph line, which means that you have two lines of the same, so they are many solutions, and they are consistent and dependent. By solving the two equations in number 3, you get two lines that are parallel because they have the same slopes but different y-intercepts, so they're graphed over here on the right. Okay, they do not intersect, so there's no solution, and therefore, because there's no solution, they are inconsistent. Hey, don't forget, remember, do your best, forget the rest. Have a great day. Night.